Okay, so now we're going to take a look at how to carry out hypothesis testing using the chi-square statistic. So the type of question that fits this particular kind of hypothesis test is there written in front of you. In a survey of 500 bankers, makers, sellers and farmers were asked to express their opinion on their business prospects for the coming year. The options were increased activity, decreased activity and no change in activity. The results are shown in the table below. And the question then, test the hypothesis that there is a difference in the true proportions of the expressed opinions for the four types of business. So what does that actually mean? Well, what it means is this. For example, if we take the bankers information here, where it splits the bankers, 40 of them said they expected increased activity, 15 expected decreased activity and 20 said they expected no change. How does that ratio, how do the proportions given there by the bankers compare to the others, the makers, the sellers and the farmers? So what we do is we need to compare each of these columns to the expressed opinions for everyone who took part in the survey. So we're going to need to do some adding up and so on. So I'm now going to switch across to Excel and the aim of that will be to let Excel do the hard work with the calculations while we focus on what it is that we're trying to learn. So let's bring up Excel. Here we go. This is something I prepared earlier. Same question at the top there, the table of results at the top, and underneath all of that the chi-square value table, the table from which we can look up the expected value of the chi-square statistic given a certain significance that we're searching for and given the number of degrees of freedom in our result. Okay, we're going to come back to that table in a second. So first of all, let's just take a look at the results as we go across wise. So there are the totals then for the all of the people in the survey. 250 expect some increased activity, 135 decreased activity and 115 expect no change at all. And the aim of our test will be to see if that ratio between all of the different pieces is matched more or less by each of the individual groups as we examine those through each of the opinions expressed. Okay, so what we're trying to do is to find out what the expected value is compared to what we observe in the actual survey. So let's just get our numbers up again. So here are the totals that we require, and what we're going to do now is ask if the bankers, 75 bankers, if those results were split out in this ratio here, what values would we expect? So let me just, first of all, before we go on and do that, let's just say take a look at the hypothesis that we're going to frame. It's a good idea to frame your hypothesis, say what your significance value is and choose your cutoff value before you do the actual calculations. That will avoid any tendency to favor one thing over another. So let's take a look at the hypotheses first of all. Okay, here are the two hypotheses. There's a null hypothesis, H0, where we say there is no difference in the true proportions between each opinion for the four types of business, and the alternative hypothesis that there is a difference in the true proportions between each opinion for the four types of business. And our aim is to get a chi-square statistic which will allow us to decide to either keep or reject the null hypothesis that we've written down there on the page. Alright then, so let's just take a look at the test statistics that we're going to use. I've taken these from the table here. There are 6 degrees of freedom. We get that by counting the number of columns and subtracting 1 to get 3. counting the number of rows, 3, subtract 1 to get 2, and multiply those two numbers together. Okay, and that gives us a value of 6 degrees of freedom. Our chosen significance value 0.05, and if we look in the tabulated values down below, 12.59 is the cutoff point. So if we generate a chi-square statistic and it's more than 12.59, we will be able to reject the null hypothesis, because the difference between the observed values and the expected values will be too great. Okay, so let's just move on down now. Let's take a look what our expected values come to. Okay, so here are expected values, and the way these are calculated is reasonably straightforward. Here we have 75 bankers, and if they distributed according to this ratio here, then these numbers here are the ones we would get. So 75 multiplied by 250 500ths, which is a half, gives us 3750. This one here, 75 multiplied by 135 500ths, and so on for the rest of the table. And that generates a table now of expected values. Our next step then is to subtract the expected values from the observed values to see what that difference is. We're trying to find the variance between what we observe and what we expect. So when we do that, okay, this is what we see. We get these values here. All right, and an important feature to note if you're doing these calculations manually is that all of these values here, when you add them up, should come to 0. You can see that down in the status bar at the bottom of the spreadsheet. The average is 0, the count is 3, and the sum is 0. All right, once we've got those values, then the chi-square statistic is you square that value and you divide it by the expected value. Okay, and what do they look like? Let's just show those particular things there. That's what you get. When you take those values, you generate another set of values. Some of them are above 1, most of them appear to be below 1. So this is quite a low value chi-square statistic. And the actual chi-square statistic is quite simply the sum of these values here that I've selected. All right, so we're going to see what that value comes to. Down in the status bar you can see it's quite low. It says 4.359. Let's just get those things, the results up like this. So here are the results then. The two values we've got, 4.359. That value is lower than 12.59, so we are going to accept the null hypothesis that there's no difference between the opinions of the 4 different businesses there. The bankers, the makers, the sellers and the farmers appear to share in general the same opinion about their business prospects for the coming year. I've also used a little function inside Excel there to generate a value for what the significance level is. It's 0.62. It's quite high. And one way of interpreting that is to say that it appears to be a 62% chance, 63% chance that the expected values, the observed values, sorry, that we got could have happened by random chance. Perhaps the number of people we surveyed in each case was not quite enough, or we just happened to randomly sample the wrong people, if you like. If we did the same survey again, we might get slightly different values, but we would hope that they would indicate the same sort of idea, that there was that we were able to actually accept the null hypothesis, that there's no reason to believe there's a difference between the different groups. So after that then we've got one thing to do, and that's to actually just make a conclusion. Okay, so a conclusion for that: as the calculated statistic is less than the tabulated statistic, it's 6 degrees of freedom and significance 0.05. We can accept the null hypothesis that there is no evidence that there is difference in the true proportions between each opinion for the 4 types of business. I hope that was clear. Thank you very much. That's the end of this little session.